Today, we're welcoming Aaryan to the podcast. Aaryan received a Merge grant to work on a new project called Phagebase. He's originally from Canada. He's been conducting research on phages at Stanford in California. He's accomplished quite a bit at a young age, working on some really cool things. So I'm really excited to have this conversation and to hear more about what he's working on, what he's interested in, what he believes in. Just to get started, let's rewind to sort of day zero, where maybe you didn't even really realize that you're interested in sort of the things that you're interested in now, but that you started to sort of go down that process, go down that rabbit hole, and try and figure that out on your own. Like, what did your life look at like at that time, and sort of what got you started?
Yeah, thank you for having me, guys. This is awesome. So I guess if the question is like, what was like the prehistory of like this entire thing? Well, I guess it sort of began when I started like studying at Stanford. I come from like a small town in northern Ontario. I love everything to do with biology, and I got like really interested in microbiology sort of before starting university. And in the first year of university, I joined a microbiology lab. And what we specifically studied was this organism called a bacteriophage. Most people sort of, when I say bacteriophage and throw around like big words, it goes like whoosh over their heads, right? So, what I like to say is we study the world's most underrated organism. And what I mean by this is that phages are probably like the world's most abundant biological entity. So these are viruses that infect bacteria, and you can think of them as sort of like the natural predators of bacteria. So wherever you'll find any kind of bacteria, which is like more or less everywhere, like our earth is just like chock full of bacteria and microbes, you'll find phages as well. And what's interesting is that phages are really good at doing a lot of things. And throughout science and the history of biotech, they've been used for a lot of really valuable applications. Like famously, CRISPR was isolated from bacteria's defense system against phages, and like a whole bunch of other really valuable tools that are sort of like bread and butter tools for biologists today came from looking at phages, but more broadly looking at viruses and looking at how microbes behave and sort of interact with each other. So that was sort of my motivation for why I joined this lab in the first place. But around this time, I started to realize like this field, even though it's existed for a long time, like phages have been studied for like a bit over 100 years now, we didn't really have a solid understanding of where like phages were situated in like the tree of life, or like even like how many phages existed or how they were related to each other. There was like a whole bunch of information, and it was sort of like siloed across the world in different labs. And there was no like unifying thing or unifying like place where all of that data could sit and people could look at it. Which I guess if you look at the analog in any other field, every other field basically has like some kind of repository for any question or piece of information that matters, like a public resource that people can look at and say, okay, this is like a globally agreed upon resource that people can use. And that didn't exist for phages. And so I guess my motivation for this entire project, which I guess we could talk a bit in a bit more detail about after, is like how do we create like a global map of all of the viruses that exist in the world? And this is like a little stepping stone to that.
It's super interesting to hear kind of about the history of phages and how people have studied them. You said that people have been studying them now for about 100 years.
Mm-hmm.
At what point did people start to realize kind of the impact of understanding phages? It seems like we're at this maybe new inflection point where people are understanding that there's even more value, and you're trying to make this information more accessible. Yeah, maybe you could speak a little bit about that, sort of the application of the knowledge. How do you think about that? How is sort of this field of research thought about that over time?
Yeah, I'd say the history of like phages is interesting in the sense that here's a field that, was a pretty big deal back when it like was first sort of emerging, and then it sort of went under the radar, and then now it's resurfacing again. And I think it's just interesting in general to like think about like what makes certain fields emerge into the vogue and then like disappear for some reason and then like reemerge. A lot of the consensus is that when phages were first like discovered, people were touting it as a new way to treat bacterial infections. But then antibiotics came, and then people started using antibiotics a lot more because they were easier to mass produce in terms of IP. You can't really patent a phage because it's a virus. It's like an artifact of nature. You can patent molecules on the other hand. And so basically most of the world shifted to antibiotics and phages sort of fell out of favor. I guess aside from the fact that they enabled a lot of scientific discoveries, they sort of stayed in academia. They were like this cool, I guess, trinket that biologists could play with, but not accessible to the rest of the world. I guess the only exception would be like the former USSR. Like while the rest of the world used antibiotics, countries like Georgia, for example, they just never stopped using phages. And so a lot of patients, even today in America, who are like on the verge of death, like no conventional antibiotics are working for their bacterial infections. They like do medical tourism to Georgia, and that's like a pretty strong pipeline. But it's an interesting case study, right? Like there's certain countries that just stayed with phages and others that didn't. And I think my personal stance on this right now is I don't think either antibiotics or phages are like superior to one another. I think they're just different approaches to solving the same problem.
That's incredible, this idea of sort of medical tourism for phages. Maybe say a little bit more about sort of your personal journey, and we could talk more about sort of Phagebase and sort of the goals of the project.
Yeah.
But you said that you got into biology when you were younger and you just were obsessed with it. How did that develop? Was it a teacher? Was it your maybe your upbringing in some way? What was the thing that got you into biology?
Well, I guess both my parents are physiotherapists. They're not doctors, but like in the dinner table, there was always conversations about like different stories of what patients had, and my parents constantly used to tell me you shouldn't join the health field or medicine whatsoever. And I guess to some extent, I'm not really in medicine. I'm more in like the biology side of things, and instead of like directly working with people, I'm trying to develop things that can be used to treat other people and extensions of that. But I have no clue when my interest in biology started. Like I just always have liked it. And so I think the only thing that's changed for me is what specific aspect of biology that I've been most fascinated about. Like I'm the kind of person that has like periods where I get really obsessed about something for like a couple months or a year, or like maybe more, and then like I switch to another thing. And so probably like began actually like building projects and doing stuff with biology in like ninth grade. So like early high school. And back then I was like really interested in cancer because it was like this really like complex, rapidly evolving disease that's just like outsmarted humans for thousands of years. And I guess to some extent, that's also why I like microbiology, right? Because these are organisms that are almost intelligent in a sense, and they have their own sort of way of behaving and like adapting to different treatments. And so it seemed like a really unique challenge for me to like sink my teeth into. And so spent like a couple of years, like just early on in high school, building like medical devices to help surgeons detect cancer cells. So like I was testing that, building that, working on patenting those things. And so I spent like a total of like 3 or 4 years just building this one device. And then at some point I realized, what am I doing? Right? Like, do I really want to spend the rest of my life working on like one or two medical devices? Do I want to be like another cancer researcher in like a sea of tens of thousands of cancer researchers, right? Like what appealed to me more was like being that one weirdo that was working on this like really like niche field that no one cares about, but like it's going to become like a really important thing later on. And so microbiology seemed to fit that bill a lot more than like cancer did, because so many people were already thinking about cancer and like so much money and so much resources were already being poured into that. Whereas microbiology, I think, is like a whole new frontier. Like we talk about space, which is like, you're exploring like these huge expanses and like traveling with a rocket, where I think like there's so much to be discovered on like a square inch of your skin. There's like a huge world that's just like too small for like the eye to see. And so there's a whole bunch of reasons that I care about microbiology specifically, but biology as a whole, yeah, that's just been like a part of my life for a long time.
And so you mentioned that once you got to university, things started to really pick up. But before then, I mean, it sounds like you were really going down the rabbit hole of microbiology. You sort of started with cancer research and building these tools for doctors. And was this basically you plus Google equals, progress in the direction that you're headed in now? Or were you working with, teachers or professors or maybe even your parents?
Yeah, and when you're talking about like hard tech and stuff like that, like it's Google is like the is what spurs you to like the ideas usually. And then I lived in like a really small town back then, like even smaller than the town that I live right now. So we didn't really have the resources to like build stuff. And so a lot of it was reaching out to like the local community college. They had like a maker space. And so like it was me figuring out electronics and then like figuring out like how to reach out to professors in like the bigger town close by and then testing it out on cancer cells and things like this. Another big motivator, I guess, was just like I had some really good science teachers, and they were really supportive of my journey throughout this. But I guess from an early age, I just had this weird thing where I didn't really like consider if things were like possible or not. I just like did them, and so I guess that's one reason why I even started those projects in the first place. Like looking back, if I knew I would have to spend like 4 years building a device, I would not have done that. But I guess it was just like being naive to some extent at the beginning.
One thing that really stands out, and even the first time we spoke when we were talking about the merge grant for your project, was just how good you are at explaining things to people and just getting ideas across in a way that's both accessible, but also you can sort of, change elevation really quickly in terms of the degree of detail that you're going into. Is that something that you feel like you learned over time? And sort of what might you give, to people who are listening to this who might want to maybe improve that for themselves? Maybe you could share a little bit about that.
I'd say writing has helped a lot in that because I think just as an art form, it's really like it's brutally realistic. Like you have a blank sheet of or like a blank screen, and then you just have to type what's in your head and like sort of wrangle your thoughts and like create some kind of order out of whatever is in your head. And then there's the saying as well, like whenever you're like a painter, you're really just painting a portrait of yourself, no matter what you do, right? And so like you're forced to like just confront yourself whenever you're writing stuff. And so ever since I started working on that cancer detection device in high school, like I just wrote like every week, like I publish a new piece of content every week. And it could be about anything, but most of the content was like long form educational stuff. In the process, I like forced myself to like learn things just so I could write about them, just so I could have something to write about at the end of the week. So one day I was like, oh, I want to learn about like how the atmosphere works. So like I like went through Yale's lectures on like climate change and the atmosphere, just so I could have material to write for the next week. And that's basically what I did for like 100 weeks or so. And I still write like newsletters and other pieces of content today. But the fact that I had to put my ideas down in a permanent form and then share them with people, like that is one of the best forcing functions that I found to get good at explaining things to other people.
And was there some sort of goal for that other than personal learning? Were you trying to build an audience? Were you just trying to get better as a writer? What was sort of the motivation behind that?
I think it was a combination of those things. I learned from a couple of my good mentors that like it's good to have like a community of people that are just, even if they're not like involved with what you do every day, that are sort of like looking at you from a distance, and that's helped a lot. And even looking back, a lot of like the opportunities and like let's say places that I've been invited to or programs that I've been a part of, like I learned about all of them through people that like I never even met personally. They just like emailed me one day like, oh, I read this article, I thought it was cool, by the way, do you know about this, right? But I guess beyond that like utility perspective, I eventually learned to enjoy writing because at one point I realized that like there was just like so much excess energy in my brain that I couldn't like let out when I was in school. And so like the only way to like get rid of that energy or to like blow off steam was like writing. It's almost like if you have like excess physical energy, like you go out for a run, the equivalent of that for me mentally was like writing.
The input and output of it is interesting to me. I think like I'm used to sort of hearing about people who are maybe more into like writing code or building companies, and you hear a lot about how you take like inspiration from things that you read or things that you watch, and then you create products. And I think I hear about it less in these more like research and academic settings. So it's really interesting to see sort of how that is something that you completely wove into your learning process with this. I'm curious, like, from doing this at home, doing this with you and yourself, to now sort of studying at Stanford and researching in this lab. What has that process like looked like, and has that process changed at all?
When I first came to Stanford, I was really excited about the fact that everything that I was doing alone, I could now do with a whole bunch of other people, because that's sort of what I was looking for. Like I couldn't really find a community of people to work around where I lived geographically, and so that was really helpful, and it helped me grow a lot as a person to like. Because I think there's a layer of you're building something, and if you're building it alone, you can go like pretty fast. Like there's no one to stop you. But I think like when you work in like a lab or a company or like a community, or in this case like a whole institution, there's also the whole lesson, and the really important lesson of like how do you get other people to work with you. And I think this is like this sort of perennial problem that like sort of everyone faces if you have a mission, right? It's like in biology especially, like the difficult thing is has never been like coming up with a really cool technology. Like we have so many cool technologies in biology, right? The issues often are like regulation, or like convincing people that this is something that's okay, right, to like let out into the world. Or even at the more micro level, like how do you convince your professor to let you do a certain experiment, right? Or how do you convince other people to help you, like sequence your phages, for example? Like all of this is it's like a whole nother art, and there's no like algorithm to it, but I think it's been equally important. So that's something I've learned a lot at Stanford. And yeah, it's sort of been like a force multiplier on whatever I wanted to do, because like there was always a cap on how much I could do before with just like the number of hours in a day, but having other people to help you is like a pretty big superpower. And I think even before that, like being able to ask people for help is also is also something that it took me a long time to learn.
Yeah, so I'm curious actually to hear more about that because obviously you're young, but obviously you've also sort of started your track record a lot earlier than most people do. How do you go about, convincing people to work with you? We'll speak about this in a second, I'm sure, but you really incorporated that into how you build Phagebase,
Mm.
sort of getting people to help contribute and, just like you said, act as force multipliers. How would you recommend people with small track records do that for themselves?
Reminds me of like the very first time I sent a cold email, and like I had no idea like how or what even this was, right? Like I had no clue that you could just like reach out to people and like they were willing to help you, like without even knowing anything about you or your background or like being your friend. And so I still remember vividly, like I wanted to like I had like this little prototype of my cancer detection device, and I wanted to test it in a lab, right? I never set foot in a lab before. I lived like the closest lab that did anything like this was like 100 miles away or something. And I just emailed like 50 different professors and like dealt with some pretty bad like success rates with that. But then eventually there was one professor, Dr. Martin Holsick, who still is a professor at Carleton University in Ottawa, Canada. He was like the first person to like reply to me. It's like, come to my lab like on the weekend if you can. And that just like was a huge unlock for me, because like, okay, sure, like I had to send 50 emails to do this, but maybe this is an art that you can get better at. Yeah, since then I've probably sent like thousands of cold emails, and that's given me a lot of opportunity to like hone the skill of asking people the right way. A lot of it has also come from reading. Like there's a great book by Robert Cialdini called Influence, or The Principles of Influence, and like just reading a lot of psychology and understanding like you know what gets people to do things, what motivates people, and how do you align your work with potentially their motivations has been really useful. But I think like it all just in a funny way comes back to the golden rule. Like instead of thinking about what you want, right, think about what the other person that like you're asking wants, right? And that tends to help a lot. So like being earnest.
Maybe we should transition to talking more about the project. Maybe we can start with, just restating exactly what it is. And then after restating what it is, we can talk a little bit about sort of the origins of it. And then we can kind of get to where we are today with it.
So right now I'm building a website called phagebase.com. Feel free to like type it in if you're listening and check it out. The one liner is that Phagebase is right now the largest visual database of phages that exists today. And so what that means is we have over like 1,100 unique phages in one website, and you can search up these phages by the bacteria that they infect, or like you can look them up based on their images. You can download as much data as you want. It's fully open access, fully public. And yeah, people around the world are finding it valuable, which is cool.
It's really cool. And what was sort of the genesis for that? We talked a little bit about your interests. We talked a little bit about your studies. But what was the thing that got you to say, somebody should do this, and that somebody should be me?
It goes back to like this one conversation that I had with my old lab mentor. His name was Arna. He's from Germany, and so like one thing he was trying to do is like whenever you grow up phages, you like get a culture of bacteria. It's like this nutrient broth with bacteria swirling around. Then you like add phages in, and then if you leave that overnight, the phages like infect the bacteria, replicate inside of them, and just like propagate a whole bunch. But then the goal is how do you like purify these phages out of the bacteria? And one of the things you need to know is like how big is your phage, right? Because the machines that we use are sort of like glorified filters, and you need to figure out what pore size you use for this filter so you can like keep the bacteria separated from the phages, right? Just based on their size. And so one thing that really bothered Arna, he was pissed one day, and he was just telling me like, I want to know how big this phage is, and I have no clue how to do it. And we spent like 3 hours together trying to figure out how big this phage was, when it's really as simple as if there's a micrograph or like a microscope image of the phage with a scale bar, you can just like figure out how big the phage is. But like it took us 3 hours to find that information because it was in like some labs, like a third file directory and like some really janky website. And so that sort of set the seed for like why is this a thing, right? Like this is a pretty common phage. Why do we have to spend so much time finding a really basic piece of information about it? And then I thought of the more broader question, like why does this happen just so often, like even beyond this phage? Like why is this a general condition of like phage research today? And from all of the other fields that I'd been in, like I think it was helpful to have been in cancer before. Like cancer is a really well-developed field with like a lot of well-organized information. It didn't make sense to me coming from that field that like this was the case in phage therapy. So I guess that just seemed like an obvious problem, and it was something that I thought I could solve pretty easily by building like an Excel sheet, which eventually evolved into an Airtable. And basically for the next 2 months, it was just me going through papers, taking screenshots of phages and their like microscope images, and then like manually typing in all of this data. And so now we have about 1,000 images, most of which was like our elbow grease.
Very cool. And when you sort of think about like where this can go, how people are contributing to it today, yeah, how do you think about that? You're not the only one who's contributing to it now. How did you get sort of your first contributors, and like where do you think this is going?
I think in our past conversation, like this was a pretty big problem, and I'm glad it's not as big of a problem anymore. I think whenever you have a situation like this, there's like the famous cold start problem, which is like if your database has nothing in it, no one's going to want to contribute anything to it. And so like it sort of needs to reach a critical mass first, and often that's like you adding data yourself, and then ideally you get to the point where it becomes like this self-sustaining community where people say, hey, this is like a place where I can publish my data. Maybe there's some benefit to me because like people will see that I posted this data. It'll help me gain some credibility. And then other people can read that data or like use it for their own research. But like there needs to be a certain threshold that you reach first. Fortunately, that's something that we were able to do just with a lot of work on our own end. Like getting past 1,000 phages was a pretty big milestone. And another thing that's been helpful from the advice that I got from both of you is a lot of the people that end up using this site are really like diehard phage enthusiasts or researchers. And the insight is those people aren't just like randomly distributed across the world. Like there's pretty small social circles and that they exist in, and a lot of the same people know each other. And so one of those communities was like this newsletter that was run by my mentor at the lab that I was working in, and it had like 1,500 people that were like researching phages and like heavily involved in this space and had like a lot of influence and whatnot in the field. And like for context, 1,500 people is probably like half of the phage world, right? Like it's not a big world right now. And so I was able to like publish a little bit about Phagebase and that, and that's brought a lot of traffic, but also like spreading word about Phagebase through people in my own lab and their like secondary connections has been really helpful. That plus like word of mouth has sort of been the strategy.
I'm curious to hear your thoughts on the sort of unrealized potential of phages. I mean, you
Mm,
mentioned this sort of earlier on in the conversation that it sort of went from being this very popular sort of discovery, then it went sort of underground, and antibiotics sort of picked
mm,
up the pace. Tell us more about like what you see as the future of the industry that you're building for.
And just really quickly, I'd
yeah.
love to add on to that question, which is,
Mm-hmm.
not just what you see with the future, but how Phagebase can play a part in that. Like having
Great.
access to this information, having more people contributing.
Well, I guess the most obvious application of phages today is like an alternative or a complement to standard antibiotics. But I think the catch here that's slightly more nuanced is that by definition, an antibiotic is a static solution. It's like a molecule that doesn't change. Okay, and as a pharma company, you spend $2 billion developing an antibiotic over like 10 years, and then 6 months later, like half of these bacteria are resistant to your antibiotic because you're pitting this static molecule against a living system that has the ability to adapt. Like natural selection is going to win out every time. Whereas phages have been predating on bacteria for billions of years. And the reason they can do this well is because they adapt too. They like viruses aren't alive, but they definitely mutate and they have the capacity to adapt. And this allows them to sort of be a lot more resilient to when bacteria try and outsmart them. And so part of the reason why antibiotics are becoming less and less attractive today is because it's just harder and harder to make one that works. And if you look at like the graph of new antibiotics over time, there hasn't been like a new class of antibiotics since the 1980s or 90s. A lot of pharma companies continue to make more antibiotics as band-aid solutions because that's really all they know how to do. And phages are still, I guess, seen as a risky solution. But I think more broadly, phages are really interesting as biological tools. One thing that a lot of phages can do really well is they have their genome and they have like this shell around their genome, and a certain kind of phage is capable of sort of taking its DNA and integrating it into the DNA of its bacteria. And you can actually weaponize this as a really great tool for like editing genomes in general. And so this is used pretty often in gene delivery in biology today. It's already like a multi-billion-dollar industry. And so that's another application. Another cool thing is that you can think of a phage as like a Trojan horse, where you have DNA. If you heat a phage up to 50 degrees Celsius, it'll sort of like open up, and then all of its DNA sort of spills out, and then you can fill it with like a chemotherapeutic, for example. And then the phage reseals itself. And then if you have a cancer, for example, cancers tend to have higher concentrations of various bacteria because you can think of a cancer as like an immunoprivileged environment, in the sense that for these cancer cells to grow, they have to learn how to evade your immune system. And in this sort of safe haven, a lot of bacteria can end up growing because that area is sort of shielded from the immune system. And so if you can get a phage to target the bacteria in this cancer, they can like sort of just release this chemotherapeutic into the cancer and destroy that tumor. So there's a whole bunch of different applications. Phages are being used as alternatives to electrical wires because if you look at an image of a phage in a microscope, their tails are really long and flexible, and some of them can conduct electricity. One application that I'd really like to see, and I think is going to happen soon, is like phages in like food, for example. Whenever you ferment things, like with bacteria, one thing that's a huge issue is phage contamination. So like milk companies pay a lot of money to like avoid phage contamination. Beyond that, if you use the same payload approach, you can fill phages with different flavors, and you can imagine like a sort of phage seasoning in like high cuisine. But like there's a whole bunch of ways you can use phages, and like there's the whole idea of like, oh, maybe you're taking like a solution and like looking for a whole bunch of problems that like don't exist. But I think at the end of the day, phages are really interesting artifacts of biology, and there's a whole bunch of ways beyond just like antibiotics that you could think of creatively using these viruses.
So you're kind of in this logging stage with Phagebase, where you're creating this database of information. You have, I think you said 1,100 or so different phages in there now.
Yeah.
Beyond logging, what else is interesting to you about Phagebase?
So I think we're very much in the infancy of like we have a broad amount of data, like we have a lot of phages that we're covering. Of course, that's also going to expand, but I think the real value here is gathering a community around phages that also like is able to get more people interested in phages in the first place, because this is not merely a tool that like rounds up everyone that's already interested in phages. I think the fact that there is a tool that's globally accessible will get more people to think about phages. So that's like the first effect. The second effect is that if you have a community around phages, you can get better exchange of information between people. So a feature that I'm trying to work on right now is a place where we can highlight any of the papers that are created or published using data from Phagebase. And so, this is an incentive for people to like use data from Phagebase, which is awesome. But B, it's a place where people can highlight and share each other's research, and also a way for people to communicate with each other. That's another thing I'm working on, like sort of a forum for people who use this site to talk to each other. And just like anecdotally, collaborations in labs happen like from like really close labs that work with each other already, or like really close friends, or word of mouth. And that's really limiting, because you're limited by either geography or, I guess, existing friend circles. Whereas if you use a site like Phagebase, or like a platform where everyone from around the world who's thinking about phages exists in the same place, then you're not constrained by geography anymore. You're able to collaborate with people that are working in potentially anything, and that really expands the space of things you can do together, right? Like I think of it like chemical reactions, right? Like if you only have two molecules, like how many like reactions could you have, right? Like if you have 1,000,000 molecules in the same vat that's stirring around a whole bunch, you get room for serendipity.
And I guess, like, obviously, right now you're building things that are just like immediately useful and interesting to phage researchers. I imagine that, there may be people listening who think that maybe they're interested in biology. Maybe they have some idea of what phages are. Maybe they don't yet.
Yeah.
Say someone is like listening to this and they're thinking like, okay, there are obviously like a lot of possibilities of what I could do with phage research. Like, what are the first sort of like 3 steps that you would tell someone if they wanted to sort of like go down the rabbit hole and see how far they can get?
I think the first step, and I think what got me interested in phage therapy, was this video from Kurzgesagt. He makes like these really awesome animated videos, like super high quality, but like also super digestible to like, even if you don't know like a whole bunch of biology, like watch Kurzgesagt's video on phages and phage therapy, right? That's like level 1. And then 2 is maybe watch like BBC's 1 hour like history of phage therapy to get a better idea of like what phage therapy looks like, sort of how it's used today. And then 3, if you're involved with like an educational institution, like I don't know what the demographic of like Merge podcast listeners is, but like if you're in college or university, or you're like pursuing some kind of education, try and reach out to like a lab that works in phage therapy. Like that's probably the best way for you to understand like what the field is actually like right now, because I think so much of what I've learned in this field hasn't come from like reading books, but like actually like doing experiments. I think that's just like the reality of biology and a lot of, I guess, hard tech.
Super actionable. Really interesting stuff. Oh, by the way, for people listening, we'll also make sure to put all the links to what he was just talking about, BBC episodes,
Awesome.
the YouTube videos. We'll put those in the show notes. So be sure to check out the show notes after this.
Cool.
This has been a great conversation. We usually talk with people a little bit about sort of their experience getting a micro grant and sort of getting funding for their projects. I think you're the first person that we've had on the podcast who actually got a grant from the Merge community versus from some other micro grant initiative. Maybe you could just speak a little bit to what the experience is like how the Merge grant has maybe helped you, if it's helped you.
Yeah, so I guess what makes Merge really interesting to me is that in the grant space, there's like really huge grants, say from like effective altruism, where they give you like 100K, which is like really daunting if you're like just starting a project. Like part of you thinks like, do I even deserve that much money? Like I'm not at that stage yet. And with that money, of course, comes like either consciously or like subconsciously, like this huge like burden of expectation on you. Like I have to like deliver something huge, right? And on the other hand, there's like grants where that are smaller, but then they also expect a lot from you. I think what's been interesting about Merge is like the amount of freedom that I've had is pretty cool. So I think the interesting case about this project was like most of the grant was like Airtable credits, which was just like fuel to help the project go forward, and that felt a lot more, I guess, refreshing to me than receiving a whole bunch of money. I'm like, I don't want money. Like, I just want the ability to like take this to the next level, and like whether that's money or whether that's just the ability to expand the database, like I don't really care. So that's been something that I've really appreciated about Merge.
That's awesome. And maybe the last question here, like, what are the questions that we should have asked, or what was something that we should have asked that maybe you think we should talk about before we wrap up? It could be about your personal background. It could be about advice for builders or people who are sort of in a similar position as you were before you started Phagebase. It could be something completely off the deep end, like completely unpredicted on our part. But what should we talk about, or what should we have talked about?
This is like the first time I've actually had the ability to like say something that a lot of people can listen to. So for anyone that's like, I guess, in the same position as I am, I guess, like somebody who's like just starting and getting into science, and like working in a lab, I guess if the question was like, what's one thing I could share with people in that position, I think it's like there's so much value in like as a scientist learning about things other than science. Like part of how Phagebase was like even created was like me being in another field, not outside of science, but like I was working in cancer and now I'm in microbiology. And there were things that were obvious to me as someone who was thinking about cancer that weren't obvious to people working in microbiology. But I think even beyond that, like I don't think you're complete as a scientist without having like a solid understanding of like history and everything that came before you and like art and all of these things. Like there's the value in it isn't like, oh, you're going to get like a scientific idea from looking at like a painting or whatever, but like the idea is like, there's so many people that have come before us and they've made like so many mistakes and like they figured so much stuff out. So even if like somebody hasn't worked on the exact same problem that you've worked on, someone's definitely dealt with the same sort of like pattern of problem or like something that's extrapolated from what you worked on. And I think there's just like so much to be learned from like previous scientists and previous like creators and founders and all of these things. So like just like something that's helped me a lot and where a lot of my ideas have come from unexpectedly are like listening to podcasts of like different founders and creators and inventors and artists.
What a great way to wrap it. I think we need to revisit this at some point and do a whole podcast just about sort of inspiration and ideas from outside of your own sort of like field and focus area, because it seems like there's just so much that you can learn from art or from another industry or from another area of research, that when you have that information and then you apply that, even if it's in some sort of abstracted way towards the things that you're doing, you start to see patterns or you start to see holes and areas that maybe should be done differently. And you only see that by, as you were saying, kind of having these other experiences that are kind of different than the experiences that you would have if you were just entirely focused on that one area. Man, it's been great to have you on. We're such a big fan of Phagebase. We've been fans ever since we first talked about and got you the Merge grant. It's been awesome to see the progress. Yeah, we'll be sure to link everything, and it's great. We're super excited to see what happens over the coming months, and we'll hopefully check in again soon.
Okay, thank you so much, guys.
So we just wrapped. That was super interesting. It's really interesting, especially because we had spoken with him for the Merge grant interview. We've sent a lot of emails back and forth, just reading his updates, giving feedback, giving advice. Just an awesome person working on a really interesting idea. And I think there's something really neat about the fact that this is an idea that feels kind of quaint in a way. He said it himself. There's 1,600 people on this newsletter who got information about Phagebase. That's about half the people who are doing work with phages right now. And the question becomes like, well, how big can this get? And I think that the question really becomes, how big can this get, in the sense of how many people start interacting and caring about phages. And it seems like we're in this place where phages are going to become more and more important, and we're going to start to learn more and more uses for them. And it seems like he's going to be contributing in a major way to that. So it's, 3,000 people now. Is it 30,000 people a couple of years from now? Is it citizen scientists? Is it more researchers sort of using phages in different applications? Just really interesting conversation. And I just always love hearing about how he thinks about things.
Yeah, I think the way that people can listen to this and sort of extrapolate certain tactics and ways of thinking about things and how he approaches building things is really cool. I think, what he spoke about, how he has this input, whether it's, movies he's watching or books he's reading or completely unrelated things, and how that can sort of better inform and add, additional perspective to the real work he's doing and make it better, I think is really interesting. As well as like how, starting out with no track record, trying to get people to, let him study in their lab or answer questions or whatever it may be. I thought that was very interesting as well. And it's something that he continued well into sort of working on what he's doing now, where he's not the only one anymore working on, adding these manual entries to Phagebase. He's building his own community from scratch, and how that came from initially like a limitation, living in a rural town in Canada, a very small town, where the nearest research lab was, he said, like 100 miles away. That was a real limitation. That could have been a non-starter, aside from the fact that he decided it wouldn't be. And so I think that's really cool, and something that people can maybe take away from listening to the episode.
I think the other thing that you touched on that I want to maybe add on to is this idea of, there aren't that many people who are working in, let's say, research, who would necessarily apply kind of like startup prototyping methodology to solving a problem in research. And I think it's the fact that he casts that sort of wide net around influences and inputs and just learning that enables him to say, hey, like, this is a tractable problem. It requires work, but we can prototype something here. We don't need to build anything super fancy. We just need to aggregate the information. And if you aggregate the information and you make it accessible and you talk about it, people, if they find it valuable, will start to contribute to it, will start to utilize it. And I think that that's really cool. And I think that was the thing that got us really excited about supporting the project, is that he was not waiting around and he didn't have any, talk about high agency, sort of the opposite of like a helplessness, right? Of, oh, woe is me. It takes 3 hours to find this really basic information. I guess I'm just going to spend 3 hours every time I need to find this basic information. He's like, no, like we can solve that, and we should solve that, and somebody should solve that. So why not be me? Super cool. I'm really excited to see what happens with Phagebase over the next couple of months and the next couple of years. And we have to have him back on at some point to do a part 2. But I think this is a good place to leave it.